All right, we are looking at 13.7, where we're going to interpret stem and leaf plots and histograms. So first thing we're going to do is we're going to look at stem and leaf plots, and then we'll look at histograms. So looking at a stem and leaf plot, it says data displays that is organized by their digits. So the stem is talking about the leading digit. The leaf is your very last digit, and a key is always required because sometimes uh, these stem and leaf plots can be talking about values in hundreds, values in thousands, or values in tenths, hundredths, thousands, stuff like that. So you need the key in order to be able to discover what uh, what the stem and leaf plot is actually supposed to represent, or how you're supposed to create it correctly with the data that is given to you. So first thing here, they're asking us, it says a software developer advertised a position at its home office. The list below shows the number of applications the office received per day. It says make a stem and leaf plot of the data. So one of the things that we have to keep in mind when we make a stem and leaf plot is we have to make sure that our stem and leaf plot is in order from least to greatest. So, and in this particular instance, we are looking at um, values. Looks like the largest value seems to be 9, and the smallest value is 9. The largest value seems to be 56. So it looks like they're all kind of in like values of 10. It's probably our best bet for making this particular stem and leaf plot. So what we're going to do here is I'm just going to make a preliminary stem and leaf plot. I'm not going to put it in any particular order right away. I'm just going to kind of make a list of the values that are given to us. So it looks like, or actually, no, it looks like 8 is the smallest one here. But anyway, so what we're going to do is I'm going to use the stem as my leading digit. So my leading digit is going to come from values that are like located here, located here, located here. So since there's not two digits with 9 and 8, I'm going to put that as 0. So the uh, leading digit, the stem, I'll start with 0, and looks like I can put 1, 2, 3, 4, and 5. So what I'm going to do is just kind of make a list, not putting them in alphabetical order right away, but this will just help me out when I want to finish my stem and leaf plot and have my finished product. So I got 9 to start with, so that goes with 0. 8 goes with 0. 24 goes with the 2, so I put the 4 there. Uh, 18 goes with 1. 27 goes with 2, 25 goes with 2, 24 goes with 2, 38 goes with 3, 32 goes with 3, 29 goes with 2, 41 goes with 4, 56 goes with 6, 42 goes with 4, 38 goes with 3, 40 goes with 4, 47 goes with 4, 32 goes with 3, 52 goes with 5, 39 goes with 3, and 41 goes with 4. So I have a kind of a preliminary list. I don't have them listed in alphabetical order yet. So now I'm going to transfer, this same stem and leaf plot using the same stem values 0, 1, 2, 3, 4, and 5. Now what I'm going to do is take those leaf values and put them into uh, numerical order. So looking at 0, it should go 8 and 9. For 1, I just have the 1 with the 8, so that's great. I look at uh, the 2, it should be 4, 4, because they can repeat. 5, 7, and 9. When it comes to 3, I got 2, 2, 8, 8, 9. 4, I got 0, 1, 1, 2, 7. And for 5, I got 2 and 6. So this is my stem and leaf plot. All right. The last thing we have to do is write a key. The key tells us what those different values represent. So normally you use the first value in the set of data. So you got 0-8. That's just going to equal 8. Sometimes you might need another one, so you can write down 1-8. That equals 18 in this scenario. Okay. Like I said, sometimes they talk about decimals, sometimes they don't. For example, like let's just say like I just put like 0.3 comma 1.5 comma 2.7. So just to give you an idea, so sometimes they can go 0, 1, 2, and then you got 3, you got 5, and you got 7. And then the key, you would go 0-3, that equals 0.3. So then that tells you, oh, we're dealing with decimals now. So that's where that comes from. If you're looking at something that's larger, so like say we had like 100, 125, and 147, something like that. You can go like 10, 11, 12, 13, 14, and say that this was 0, this was 5. I'm sorry, the 2 goes with the 12, and then the 7 goes down here. So then when you write your key, you got, so then you know that, oh, now we're dealing with hundreds. So that's what key there is supposed to help you. Another kind of stem and leaf plot, it says we have back-to-back stem and leaf plots. So this is an example of a back-to-back stem and leaf plot. So here it says, looks like they're comparing, it just shows the ages of participants in 2 yoga classes. They want you to compare the ages of participants in the 2 yoga classes. So anytime you have something like this, normally what you would probably do is figure out what the values are. So we'll call this like yoga class A, we'll call this yoga class B. So I'll go over here and I go A and I go B, and I'm just going to list the ages. So the key here, it says 20, which is 20. That comes from this value here. That's where I get the 20. And then 22 gives me 22. Remember that this is your lead digit. So it's probably a bad example. They probably should have put the 1 on there to kind of help you out. But anyway, so looks like in yoga class A, you had participants that were 19 years old. You had 22, you had 24, 24, 25, 26, 32, 32, 34, and 37. When you're looking at yoga class B, you had participants that were 18, 18, 19, 19, 20, 20, 21, 23, and 30, and 30. Okay, so it says comparing the ages. It appears that looking at the data now, when it's taken out of the stem and leaf plot, you could say that the ages in the yoga class in uh, yoga class A seem to be a little bit older than yoga class B, uh, just from observations. And moving forward, we're going to look at being able to draw a histogram graph. So, a couple things that you are going to have to do in order to draw this graph is first thing we're going to look at is frequency. Frequency, it says the interval is the number of data values in that interval, and you get to pick what the interval is for the most part, unless they specifically tell you that they want it in sets of 10, they want it in sets of 100, sets of 50, sets of 25, sets of tenths, depending on whatever the data is. Um, Usually, uh, when we're dealing with, integers, whole numbers in that aspect, a lot of times we're usually going to do things in sets of 5 or in sets of 10, depending on the range of our um, our data set. And then once you've chosen those intervals, then we're going to make a frequency table. So then we know how many times it crossed that particular frequency or in that particular interval. And then finally, we're going to make our histogram graph, which is a bar graph that displays uh, the frequency table where the bar lengths represent the frequency, and more importantly, no gaps are in between the bars. So there's no gaps between the bars. So then we can kind of get an idea of what we're trying to look at. So we have a set of data here. Looks like we got 12, 22, 18, 26, 31, 34, 17, 26, 28, 10, 20, 14, 15, 32. So what first things first, what I would do is I would choose an interval. And looking at it, looks like the smallest value is what, 10, and the largest value looks like what, 34 possibly. Just double checking. Yeah, so 10 is the smallest value, 34 is the largest value. I'm going to make my intervals in sets of 10. So, you know, so I'm going to say sets of, so in 10. Tens, I call it. So to kind of help me out, what I'm going to do is actually I'm going to make a stem and leaf plot, or at least initially, to kind of help me out. So I know I got values in the 1 spot, I got values in the 2 spot, and I got values in the 3 spot. So going here, I got 12, so 2 goes here, 22, 2 goes there, 18, 8 goes here, 26, 6 goes here, 31, 1 goes there, 34, 4 goes there, 17, 7 goes there, 26, 6 goes there, 28, 8 goes there, 10, 0 goes there, 20, 0 goes here, 14, 4 goes there, 15, 5 goes there, and 32, 2 goes there. So all this is kind of, what this is kind of doing is giving me an idea of how I can write out my frequency table. So my frequency table is going to look something like this. So I have pieces of data that go from 10 to 19. I got pieces of data that could go from 20 to 29. And I got pieces of data that goes from 30 to 39. So now I just get the count. So looks like for between 10 and 19, looks like I got 1, 2, 3, 4, 5, 6. And between 20 and 29, I got 1, 2, 3, 4, 5. And then finally 30 through 39, I got 1, 2, and 3. So that's my frequency table. I see that I have six pieces of data that fall between 10 and 19. I have 5 pieces of data that fall between 20 and 29, and I have 3 pieces of data that fall between 30 and 39. So now we're going to make the histogram. So the histogram here I got says a bar graph. So I'm going to make a list so far like the largest is. So I'm going to go 1, 2, 3, 4, 5, 6. Oh, let's go 7. All right, now all of my sets of data. So now I'm just going to make my bar graph here. Comes from 10 to 19. Over here goes from 20 to 29. And over here goes from 30 to 39. So I go up to 6, come up to 6, make my graph, bring it down. No spaces in between. I got 5, so 5's here. Bring it down, and I have 3 here, so bring it down. And there's always a possibility that you could extend these lines all the way across. Maybe you want to make the lines a little bit lighter or even a different color. So like I could just put like green right here. So this is just representing, stuff like that. I guess if you wanted to, you could put the value. So you could put 6, you could put 5, you could put 3 there also. And sometimes people color it in, using different colors or just your pencil, excuse me, will help as well. And that's how I make a histogram using the different items that that we were looking for. So like frequency table, talking about choosing intervals for a specific data set, stuff like that. And that is being able to interpret stem and leaf plots and histograms. Hope this helps. Until next time.